two-way tables and relative risk. Covered in year 12 and 2.12, all right, but revisited in 3.13 this year. So, two-way tables, often called contingency tables. The idea of this is that you're given a breakdown of a population into two different variables, two different sets of variables. Now, we've talked a lot about the fact that it should be this or not this, and that's one of the things that needs to come out this year. That generally we're talking about what's not happening or what is happening. So if we were to look at the case of smoking and cancer, correct. I mean, there should always be a reason for drawing a two-way table. Okay, so we're looking at the relationship between cancer and smoking. The opposite of that relationship will therefore be not having cancer and not smoking. So there were 75 people in this study. And we have 15, 20, 5, and 35. All right, as our data set.
How about data-wise? It's of cancer, not cancer. If we're talking about people, can you say like not cancer? Like in like talking wise?
Like not people.
Yeah.
People who do not have cancer. Not have cancer.
So they have like cancer and do not have cancer. You know what I mean? Like
Yeah, probably. Yeah, it's your interpretation once you get past there, definitely. So we were looking at cancer and smoking and what was their relationship. So we got this table out of it. The next thing we ought to do is add up our table. Should just go with the territory. So we've got 15, 40, and I can add 35, 40, 20, and 55. So we're pretty sure that 75 is our total. All right. So knowing that part, we can ask all sorts of questions about this table. The sort of questions you got last year is, given that a person is chosen at random that smokes, what is the probability they would have cancer? All right. So we would be looking at only those who have smoked, and therefore the probability would be 15/35. So a reduction of what our population is by looking at certain things. We're going to go into that sort of relationship a little bit later on in a big way, but for now, that's the sort of questions you got last year, and we're going to continue with those. But the relative risk part of it is that what I need you to think about this year is that it is probabilities. We are looking at the probabilities. We are comparing the probabilities. We are looking at that comparison as a proportion. All right? So being a proportion means that we do not have to have something under 1, between 0 and 1, because it's not a probability. It is a proportion. All right? So we have a question. What is the relative risk? Now there is a difference between relative risk and risk. All right? When we're talking risk, we are talking the average. The average, so how many people out of how many people, all right? When we are talking relative risk, we are comparing it to something else. So the risk of having cancer would be 15 out of 20, all right? The relative risk needs to have a comparison to something else. It is related, okay? What is the relative risk of having cancer for a smoker versus a non-smoker? Question mark. Or a question. All right, so we're looking at probabilities here. We're interested in the probability of a smoker having cancer and the probability of a non-smoker having cancer. And if you think about it like that, you should get the right probabilities, because that's the hardest part, is getting the probabilities right. So we're looking at a smoker having cancer. Smoker having cancer is 15 out of what? The probability that a smoker has cancer. Right. Out of 35, and the probability that a non-smoker is 5 out of 40. If you have the same denominator here, you probably need to relook at it, because most of the time it's two different things and therefore two different denominators. So those are the probabilities. So the relative risk of so the first one is on the top, therefore it's 15 over 35 divided by 5 over 40. So knowing our good fraction work, when we're dividing a fraction, we times by the reciprocal. So it's 15 over 35 times 40 over 5, which is 24 over 7. Can you give me a decimal? 3 point. Not quite 5. All right. So what does that number tell us? What is our answer to this question? Good. It's that times more likely. All right. So a smoker is 3.4 times more likely to have cancer than a non-smoker. So by using this scenario, I'm saying that relative risk is often associated with things that we really don't want to talk about. So people who are actually looking at relative risk are people like insurance companies and medical people and things like that, because they are doing that comparison of things. So the answer, smoker is 3.4 times more likely, and we probably could say about. So we could have that word about in there just to cover the fact that it's not exact. About 3.4 times more likely to have cancer than a smoker. With the evidence though, pretty sure you're not going to get that wrong, because the evidence is there that you know that that's the actual number, ... 3DP, whatever. All right.